Hello friends, myself Rajendra Mahajan presenting my one more new video on linear differential equation of nth order. Here the given equation is solve x cube d cube y by dx cube plus 3x square d2y by dx square plus x dy by dx is equal to x square. The order of that differential equation is 3. Then we have to check whether it is with constant coefficient or with variable coefficient. Here the coefficient is x cube, then 3x square and x means it is with a variable coefficient. As per the form, the given equation is in Cauchys form. Given equation is in Cauchys form. And as it is in Cauchys form, we have to use the substitution log x as z. Therefore, we get x is equal to e raised to z and that capital D as d by dz. With this substitution, we have the value for we have the value of x dy by dx. We get x dy by dx as dy. The value of x square d2y by dx square as d multiplied by d minus 1 into y, and third x cube d cube y by dx cube as d minus 1 d minus 2 into y. Here y is dependent, x is independent variable. Then we are converting it into new dependent variable as z. We are converting that x in terms of z as x is equal to e raised to z, and that capital D stands for the operator d by dz. And therefore substituting all this in this given equation, that equation becomes, we replace x cube d cube y by dx cube by d minus 1 d minus 2 into y plus 3 times the value of x square d2y by dx square is d minus 1 into y, and plus x dy by dx as dy, and that is equal to x square, but x is e raised to z and its square, and therefore it becomes e raised to 2z. Simplifying it, we get this is d into a product of these two terms is d into d, that is d square minus 2d minus d minus 3d, and plus 1 into 2 we get 2 plus 3 times d into d square minus d and plus d, and from all this I can take y as a common, and that is equal to e raised to 2z. Simplifying it further, we get d into d, that is d cube minus 3d square plus 2d plus 3d square minus 3d plus d operated on y, and that is equal to e raised to 2z. Again simplifying it, we get d cube minus 3d square plus 3d square get cancelled. This is plus 2d and minus 2d also get cancelled, and we have only d cube operated on y, and that is equal to e raised to 2z. If we call this equation 1, this becomes equation 2. A new equation. If we observe the new equation very carefully, there are two variables y and z. Y is a dependent variable, z is independent variable. The order of that differential equation is 3. Therefore, It is linear differential equation of order 3 and with coefficient 1, means it is with constant coefficient. Means the given equation, first of all we have to convert it into a linear differential equation with a constant coefficient by this substitution, a standard substitution. Log x is equal to z, we get x is equal to e raised to z. Capital D stands for the operator d by dz, and we have the values x dy by dx, x square d2y by dx square, x cube d cube y by dx cube. And substituting all this here in equation 1, after simplification we have a new equation. That new equation is LDE with constant coefficient, and we know how to solve that LDE with constant coefficient by finding CF and PI. Equation 2 is linear differential equation with constant coefficient, and then we have to solve it by finding CF and PI. For CF, the auxiliary equation is here. D cube equal to 0. Solving it for D, we get the values of D as 0, 0 and 0. Roots are real and repeated. Roots are real and repeated. And as roots are real and repeated, a way to write down CF is, it is C1 plus C2, new independent variable here is Z, plus C3 Z square, and therefore it is 1 upon D cube, which we have to operate on e raised to 2Z. And if we observe this term, it is in the form of e raised to ax. Here instead of x, we have variable z. Therefore, this is shortcut method, case 1. And as per that case, we have to replace d by a. A is the coefficient of z here, it is 2. Therefore, replacing d by 2, we get 2 cube into e raised to 2z. 2 cube is 8, therefore 1 by 8 into e raised to 2z. Equation number 4th. And then combining equation 3 and equation 4 to find out complete solution. And therefore, that complete solution is CF plus PI. Complete solution is always for the dependent variable. Here the dependent variable is y. CF we get C1 plus C2z plus C3z square. E raised to 0z is 1 and plus 1 by 8 e raised to 2z. This is the required solution, but we have to convert it in terms of, original equation is in terms of x and y, therefore the required solution also must be in terms of x and y. Therefore once again we have to convert z in terms of x, and therefore here we have y is equal to c1 plus c2z plus c3z square and plus 1 by 8 e raised to 2z. Then again converting z in terms of x, we have c1 c2z, z is log x, plus c3z square means log x whole square plus 1 by 8 e raised to z is x and its square is the required solution. or the required answer. Always convert the final answer in terms of original variables. Here the original variables are x and y. Therefore, your final answer must be in terms of x and y. If you don't convert, you may lose 1 mark. Therefore, be very careful. Always convert in terms of original variables, whatever. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel if you are not subscribed yet. And to receive the notification for my such type of all new videos, please press the bell icon. Thank you. Thanks for watching.